Okay, let's look at the first one here. We have a sample of neon gas. Neon's gas at room temperature at 550 torr and 25 degrees C is placed in an evacuated 5-liter flask. The gas sample is heated to 200 degrees C. Assuming the flask volume of the flask does not change, it's a hard container, what is the pressure of the gas inside the flask at the higher temperature? All right. So, what do we have? Do we have anything about moles or mass or stoichiometry, anything like that here? Nothing there. All it is we're taking a gas at one set of conditions. So here we have one point here, and that's got a pressure and a volume and a temperature. We'll call this point 1, and we're moving it to point 2, and it's got a pressure, a volume, and a temperature. So we know the relationship between these 2 points is that the pressure times the volume divided by the temperature is equal to the pressure times the volume divided by the temperature. And we may rewrite this thing into something that folks have a little easier time. P1 V1 T2 equals P2 V2 times T1. Same thing, just rewritten. All right. So what do we know? Well, we know that we got a pressure of 550 torr, a temperature of 25 degrees C, and a volume. So I'm going to call that condition 1. So P1 is equal to 550 torr. V1 is equal to 5 liters. T1 is equal to, what is that, 25 degrees C? But remember, we have to put this in kelvins. So 25 plus 273 is 298 Kelvin. So that's P1, V1, T1. How about the other side? P2, what's that equal to? The gas is heated, assuming the volume does not change. What is the pressure? Oh, what is the pressure? We're trying to figure P2 out. So V2, oh, it's the same thing because the volume doesn't change. And T2, well, what's going on? Oh, it goes up to 200 degrees Celsius. So we're going to have to add 273. That's 473 kelvins. All right. And what else do we have? I think that's everything. So let's go ahead and plug it into this equation here. We can say P1 is 550 torr times V1, which is 5.0 liters, times T2, which is 473 kelvins, is equal to P2, which we don't know, times V2, which is 5.0 liters, times, what's that, T1, 298 kelvins. So, plug this whole thing in. We're going to divide both sides by 5 times 298. Okay, so we know that P is equal to 550 torr times 5 liters. It's 473 kelvins, all divided by 5 liters times 298 kelvins. All right, look at that. The 5 cancels. The volume doesn't change, so we don't have to worry about it. So let's go ahead and plug it in. So we have 550. I'm not going to worry about the 5 because it divides out. Times 473 divided by 298 equals, is that 872.9? So how many sig figs are good to 2 sig figs? So 8.9 7 times 10 to the second. What is it? Liters cancel, kelvins torr, because we're looking for pressure. There you have it.